We're on the front end of the energy transition, and it's a massive change globally in how energy is produced and used. The next generation is going to see massive changes in the way energy is produced, the way it's transmitted, the way it's stored, and of course in the way it's used in transportation and everywhere. The only way for this energy transition to occur is through metals and minerals. So the energy transition presents a real challenge for the mineral processing community, because we've got to meet those needs of the energy transition going forward. So it's a very exciting time to be a mineral processing engineer and to be involved in the industry. Extremely exciting, and but also challenges to be overcome. And often when you put those two together, it creates a really vibrant community, and we have that in front of us today.
In order to increase production of these metals, we're starting to have newer mines, so newer greenfield operations have to come in, which is, what we're seeing is that there's a significant decline in project NPV, and this is coming, some of it from, the higher interest rate environment. But we're sort of seeing we're reaching this upper limit for what we can achieve through scale. So bigger isn't better, right? You got to fork out more money, and it's just getting expensive. So we really need improvements in productivity and novel technologies that can help us reduce energy, water, and mainly OpEx. How do you reduce capital costs? How do you reduce OpEx? And that's going to come with newer and more improved technologies. So we're talking about novel technologies, how to reduce our overall footprint, how to reduce, environmental footprint, how to, increase water recycle, how to use newer, more efficient, for example, flotation cells.
Yeah, I'll add on to that, Tarun. To me, what's really exciting is that we're really shifting focus on some of the minerals that we will need to be processing in the future. And in addition to that, some of the products that we're producing that will have to recycle, where we again can apply mineral processing in very innovative ways. Some of the abstracts submitted for IMPC24 relate to how we can recover some of the materials in used in batteries. So for example, some of the graphite material or some of the lithium, nickel, things like that. So how can we reuse when the batteries are at their end of life? How can we reuse and recycle that material?
Yeah, and to build on that, lithium is a great example of a commodity that is being changing dramatically. It's been used in most battery materials that are used for transportation now, and recycling of lithium is critical. And there are many ways being looked at to recycle that lithium, but also the other metals in these battery materials, nickel, cobalt, manganese, and all of these metals, can be actually recovered from spent battery materials. And the lithium business is pretty interesting, because it's grown from a very small, I would call it a niche mineral with fairly limited uses. It's grown overnight to where it's a pretty major commodity, and the demand far outstrips what the industry can currently supply. And so mineral processing is being developed right now for recovery of lithium from a whole variety of different sources.
In addition, there's other sources of metals that we're now hearing about. People are talking about recycling printed circuit boards and several other ready-made consumer electronic items. And we're seeing that mineral processing techniques are now being applied to these separations as well, which is so it's an expansion of the field, and we're seeing new knowledge being developed every day.